Shiraj classes. We have already started the important chapter of standard 10, that is triangle. This is the chapter with the maximum number of theorems. 6 theorems are already covered in our previous videos, and now we will move on to the theorem number 7 of this chapter. So what this theorem says? That in a right angle triangle, if we draw a perpendicular from the right vertex to its hypotenuse, then the two triangles which are formed on the either side of this perpendicular are similar to our original triangle, and they are also similar to each other. So now what is the meaning of this? See, in triangle ABC, angle B is 90 degrees. This is the right vertex. And BD is perpendicular to the hypotenuse AC. We know that the side which is opposite to 90 degrees is called hypotenuse. So here BD is perpendicular to our hypotenuse AC. So when we draw this perpendicular, two triangles are formed here. This is one triangle and second triangle. So we have to prove that both the triangles are similar to our original big triangle, and they are also similar to each other. That is, triangle ABD is similar to triangle ACB, and triangle CBD is similar to triangle CAB, and also they are similar to each other. Triangle ABD is similar to triangle CBD. This is what we have to prove. This is very simple theorem. Let us move to the proof. In triangle ABD, this triangle, in triangle ABD and triangle ACB, this bigger triangle. In these two triangles, angle BAD is equal to angle CAB. Angle BAD is equal to CAB. This is one and the same angle. That means this is common. And second angle, that is angle ADB. ADB and angle ABC. This is 90 degrees. Because this is the right vertex, it's given to us, and BD is perpendicular. This means this angle is 90 degrees. So now in both of this triangle, we have two angles. We got two angles are equal angles. This means the triangles are similar by AA criteria. Triangle ABD is similar to triangle ACB by AA criteria. First part is proved. Let us come to the next part. In triangle CBD, this one. In triangle CBD and triangle CAB is this triangle and our this bigger triangle. Now in these two triangles, angle C is common. Angle BCD is equal to angle ACB. So angle B is common here. Second thing, angle BDC is equal to angle ABC. This angle is 90 degrees and even this angle is 90 degrees. So what did we get here? Again, in these two triangles, we get that two angles are equal. So as two angles are equal, these two triangles are similar by AA criteria. Triangle CBD and triangle CAB are similar by AA criteria. Now we know that the axioms, things which are equal to the same thing, are equal to one another. Same rule we can apply here. So this bigger triangle is similar to this, even this bigger triangle is similar to this. So these two triangles are similar to each other. So from 1 and 2, we can conclude that triangle ABD, that is this triangle ABD, is similar to triangle CBD. So this is what it is asked to prove in here. Now let us proceed further with the next theorem. Now this theorem is Pythagoras theorem, the most important theorem. Now what is Pythagoras theorem? Pythagoras theorem is applicable for right angle triangle. It says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now here, this triangle ABC is right angle triangle. Right vertex is B and AC is the hypotenuse. So according to the Pythagoras theorem, AC square is equal to AB square plus BC square. This is what we have to prove here. Now we can say this is the continuation of our previous theorem. In our previous theorem, already we proved that these two triangles are similar to this original triangle. Same thing we are going to apply here. So what are the given things? In triangle ABC, angle B is 90 degrees, AC is hypotenuse. We have to prove AC square is equal to AB square plus BC square. Actually here it is not given that we have the perpendicular. We have to do it as a construction part here. Draw BD perpendicular to this hypotenuse AC. So when we draw this perpendicular BD, our triangle is divided into two triangles. So now, as I said, it is continuation of our previous theorem. So it's easy for you to understand now. Let us consider triangle ABD and triangle ACB. Triangle ABD and triangle ACB. So in this, angle BAD is equal to angle CAB. Angle BAD is equal to angle CAB. It is common angle. Angle ADB. Angle ADB is equal to angle ABC. It is 90 degrees. Because ABC is 90 degrees, it is already given, and BD is perpendicular, and that is the reason why angle ADB is 90 degrees. So these two triangles are similar by AA criteria. As two angles are equal, the triangles are similar by AA criteria. Now here what we have to do, as these two triangles are similar, I am going to take the proportional sides. AB upon AD, okay, AB upon AD is equal to AC upon AB. So these are the proportional sides which we are considering of these two triangles, because AB is the side of triangle ABC as well as of triangle AB. AD is the side of the smaller triangle and AC is the side of the bigger triangle. So accordingly we are taking the proportional sides. AB upon AD is equal to AC upon AB. Cross multiply. AB square is equal to AD into AC. Mark this as 1. We got one part here. AB square. AB square is equal to AD into AC. Now what we have to do? Again the little bit part of our previous theorem. Consider this triangle. Triangle CBD. Triangle CBD and triangle CAB. Means this triangle and our original triangle. We will prove how they are similar now. Angle BCD. Angle BCD is equal to angle ACD. Angle BCD is equal to angle ACD. It's one and the same. Common angle it is. Again here we have angle BDC. Angle BDC is equal to angle ABC. This is 90 degrees because BD is perpendicular to AC and angle ABC is 90 degrees. It is already given to us. So what we get now? These two triangles, that is CBD and CAB, are similar by AA criteria. As two angles are equal, they are similar by AA criteria. Now let us consider proportional sides of these two triangles. BC upon AC, BC upon AC is equal to DC upon BC, is equal to DC upon BC. Again cross multiply. BC square is equal to DC into AC. Now what did we get here? We get this second portion. And what we want? AB square plus BC square. Let us add 1 and 2 and check what we get. We have here AB square, we have here BC square. Add 1 and 2. AB square plus BC square. AB square is AD into AC. AD into AC. And BC square is DC into AC. Now in both these products, we have AC common. AC side is common. We will take that out. And the remaining terms, that is AD plus DC, we will write in the bracket. Just have a look at our figure here. AD plus DC. Where it is? AD plus DC. What is AD plus DC? It's nothing but this line AC. So AC, this bracket, this parts if we add, that is AD and DC, we get AC. So AC into AC, we get AC square. So now our final statement, this AC square is nothing but AB square plus BC square. This is very important theorem for the board exam. So what is our Pythagoras theorem? We will repeat again. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So here we complete our one more important theorem, that is Pythagoras theorem. Let us move to the next theorem. This next theorem is Converse of Pythagoras theorem. What is the meaning of converse? We can say just ulta statement of the theorem. So here what Pythagoras theorem says, that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Converse. What converse says, that if in a triangle, if square of one side, if it is equal to the sum of the squares of the other two sides, then the angle which is opposite to this first side is a right angle. This is what we have to prove now. So here in triangle ABC, AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. So we have to prove that this angle ABC is 90 degrees. For this, we have to take the help of one construction. We will construct one right angle triangle. How? One right angle triangle PQR in such a way that PQ is equal to AB. Just measure what is AB. Take the same length of PQ, and QR is equal to BC. And while constructing these two lines, we have to measure this angle as 90 degrees. So let angle PQR is equal to 90 degrees. Join this PR. So our triangle PQR is ready, where PQ is equal to AB, QR is equal to BC, and PR is the third side of this triangle. Now let us move to the proof. Now here in this triangle PQR, by our construction, angle Q is 90 degrees. And our Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So PR square is equal to PQ square plus QR square. That is by our Pythagoras theorem. But our PQ is equal to AB, PQ is equal to AB, QR is equal to BC, QR is equal to BC. So here in this statement, we will substitute this PQ by AB and QR will be replaced by this BC. So what our statement becomes? PR square is equal to AB square plus BC square. But what is given to us? It's given that AC square is equal to AB square plus BC square. It's given that AC square is equal to AB square plus BC square. PR square is AB square plus BC square. AC square is also AB square plus BC square. So from this what can we conclude? We can say that PR square is equal to AC square. And so PR is equal to AC. This is one more information what we get from this proof. Let us proceed. Now in these two triangles ABC and PQR, in these two triangles ABC and PQR, AB is equal to PQ, BC is equal to QR, this is by our construction, and AC is equal to PR. This is what we have proved here. So here three sides of this triangle is equal to all the three sides of this triangle PQR. So we can say that these two triangles are congruent by SSS postulate. These two triangles are congruent by SSS postulate. And as these two triangles are congruent by, well, right here, just right here, they are congruent by SSS postulate. And as these two triangles are congruent, angle ABC is equal to angle PQR, because corresponding parts of congruent triangles are equal. But what is our angle PQR? Angle PQR is 90 degrees. So angle ABC is also 90 degrees. So this is how we prove here that in a triangle if one square of one side, if it is equal to the sum of the squares of the other two sides, then the side which is opposite to the first side is 90 degrees. So this is what is converse of Pythagoras theorem. So in this video we have completed 3 important theorems of this chapter. So be in touch for many upcoming useful videos, and thank you so much for watching this video.